Welcome to day 7 of Unit 11, Liquids and Solids, and Unit 11, Liquids and Solids, heat stoichiometry, the calculations that we need to talk about. This is actually, I believe, the last thing that we are going to be talking about for this particular unit before we move forward with the next set of content, so let's get into it. We have to remember that there are intermolecular forces of attraction between molecules, but the intramolecular forces are bonds within a molecule. That's something that we talked about once upon a time a unit or two ago. So the intermolecular forces of attraction are the forces of attraction that hold substances together. Well, the intramolecular forces of attraction are the things that hold the atoms together in bonds. So some other things to remember is that in a chemical reaction, the existing chemical bonds are broken and new bonds are always formed. So that's the beginning part. So we take our reactants and we break bonds in the reactants and then form new bonds in the products. Energy is always put in to break some bonds, and there's energy always released when new chemical bonds are made. Because we also talked about way back when we talked about bonding at the beginning of the year, we talked about the fact that the reason why atoms bond is so that they can lower their potential energy. So we put energy in to break bonds, and when bonds form, energy is released because atoms are going to a lower potential energy state to become more stable. And the difference between the energy needed to break the reactant chemical bonds and the energy released when new product bonds are made is something that we talk about in terms of the total amount of energy for the reaction. And the difference between the amount of energy put in to break bonds and the amount of energy released when new bonds are formed is something that we call enthalpy. And it has the triangle, and you may already know that triangle is the Greek letter delta, and that means change. In science, the Greek letter delta is change in something. So this is the change in enthalpy of a reaction. So it's the amount of energy. Remember, enthalpy is defined as the difference of the amount of energy put in versus the amount of energy released. So we have two types of enthalpy. There's positive enthalpy and there's negative enthalpy. Positive enthalpy is representative of an endothermic reaction. It means that heat is being absorbed into the system. More energy is needed to break bonds, and because reactant bonds are stronger. Energy is a reactant in positive enthalpy equations. So the example would be if I take ammonia and I separate it into nitrogen and hydrogen, I need to put in 92.4 kilojoules per mole of energy to break all of the nitrogen and hydrogen bonds present, and that amount of energy happens to be the energy that we put in. So positive enthalpy reactions, we always add energy to the reactant. And look at that in terms of a positive enthalpy reaction. In this case, because we put energy in, it was on the product side, and it was a positive enthalpy. So we needed more energy to break the bonds of the reactant for positive enthalpy. In a negative enthalpy reaction would be exothermic, and that's heat released by the system. So more energy is being released from the making of new product bonds. And that's because the product bonds are stronger than the reactant bonds, and as a result of that, the energy is a product in the equation as well. So in the case of methane, CH4, being burnt in the presence of oxygen, we produce some carbon dioxide and we produce some water, and we produce a lot of energy. In this case, 802 kilojoules per mole of energy. The actual enthalpy value is negative 802 kilojoules, as referenced here. But when we put it in the equation, it's part of the product. So one of the things that we make is carbon dioxide, another thing that we make is water, and another thing that's released is energy. Now I'm going to go back, and we needed less energy to break the bonds than for the reactants for the negative enthalpy. So there are a couple types of calculations you're going to have to be able to perform, and they're not very hard. The first thing that we have to look at is whether or not the reaction that we're talking about is endothermic or exothermic, and based on the information that we're given, you should be able to tell. In this case, the reaction is exothermic, and I know that because the value for the enthalpy, which is the change in energy from the reactant bonds being broken to the product bonds being formed, is negative. So that means that energy is being given off. So I have what my reasoning would be negative change in enthalpy, or so negative delta H reaction. So that's what it tells me by just looking at the data that's been given to me. Now, when I'm asked to rewrite the equation so that the enthalpy change in the reaction is included in the reaction as either a reactant or a product, we would write something like this. So here are my reactants, and here's my product, my balanced chemical equation, and because this is exothermic, I'm going to add the amount of energy in the enthalpy change. So in this case, it would be positive. I'd be adding 185 kilojoules per mole. If this was an endothermic reaction, the delta H would be positive, and we would be adding it to the reactant side. So what can we do with this information? So the question says, what is the change in enthalpy when 1 gram of chlorine reacts? So I'm going to use some stoichiometry to figure this out, but before I really get into the stoichiometry, I want to make note of the fact that the coefficients here are 1 and 1 and 2. So, and we also want to make note of the fact that the enthalpy, the change in enthalpy is negative 185, and the unit is kilojoules in 1 mole. And so what we're looking for is we're looking for our value that's associated with this. So what we're going to do is we're going to take the 1 gram of chlorine, which in this case is Cl2, and I'm going to change it to moles. So I need to calculate the molar mass of chlorine, and the molar mass of chlorine is 70.90 grams of chlorine in 1 mole of chlorine. And at this point, I'm going to also go ahead and I'm going to add in the enthalpy value. So I'm going to put my enthalpy value here, and it's going to be negative 185 kilojoules per mole. But the issue is that in this particular reaction, the balanced chemical equation does tell me that this would be 1 mole. So when I plug this into my calculator, I take 1 divided by 70.90 times 185, and that's a negative 185, and I get something like 2.6 with 3 sig figs, so 2.61 kilojoules of enthalpy or energy. And then the last one we have to do is we have to take the change in enthalpy when we have 3 grams of hydrochloric acid or HCl being formed. So I'm going to do a similar process, 3 grams of HCl, and I'm going to convert that to moles of HCl, and I'm going to calculate the molar mass of hydrochloric acid, which is 35.45 plus 1.01, so that's like 36.46 grams of HCl. And then I'm going to take the change in enthalpy for the reaction, which is negative 185 kilojoules per mole, but this time, because the balanced chemical equation has 2 in front of the HCl, I need to put a 2 there. So when I go to calculate this problem, I will take the 3 divided by the 36.46 times 185, which happens to be negative, divided by 2. And I get something like 7.61 kilojoules of energy formed. Or kilojoules of energy, it's part of the reaction. So what you're going to have to do for homework after you watch this video is you're going to have to complete worksheet, I believe it's 7, and it's going to be working on this particular reaction, or no, it's worksheet 8 actually, but it's going to be working on these types of reactions, and they're not hard as you can see, but you're going to have to be able to identify whether or not the reaction is, a reaction is endothermic or exothermic based on the enthalpy, and then you'll have to do some basic calculations. If you have any questions, reach out to me and let me know, and I'll do my best to answer them. Other than that, have a good day.